Section 2, Video 2, Solving Quadratics via Graphing. If we are given a function, one way to graph it is to do an XY table, and we would typically plug in easy numbers, and you definitely with quadratics want to plug in positive and negatives. So negative 3 squared is 9. Negative 2 squared, quantity squared, now remember that, it's quantity squared, is 4. Negative 1 squared, quantity squared is 1. 0 squared is 0. And then we have similar answers for those. Now applying those points, we have, cannot fit the first one on there, but we can fit negative 2, 4. Negative 1, 1. 0, 0. 1, 1. And 2, 4. So here's your parabola. The question is, what's the solution? And we said with graphing, the solution is or are x-intercepts. In this particular case, you have one solution, and the solution is 0. The next one, same scenario. XY table. If you plug in negative 3, negative 2, negative 1, 0, 1, 2, and 3. Negative 3 quantity squared is 9 times the negative 3 is negative 27. Negative 2 quantity squared is 4. 4 times negative 3, negative 12. Negative 1 quantity squared times negative 3, negative 3. 0 will give you 0, and 1 will give you negative 2 will give you negative 12, and so on. So we plug that in. We have one number we can't fit. Negative 2, negative 12 fits. Make this a little bit easier to do. And we have negative 1, negative 3. We have 0, 0. We have then 1 and negative 3, so it's symmetrical. And 2 gives us negative 12. So here's our parabola. Solutions again are x-intercepts. So again, in this case, our solution is 0. Our next one, we have XY table. Plug in our negative 3, negative 2, negative 1, 0, 1, 2, and 3. When we plug that in, we get, again, this means we're going to go 2 times negative 3 squared minus 8 times negative 3 plus 7. So remember, negative 3 quantity squared. That's important. When you do that, you get 49. You get 31, you get 17, 7, 1, negative 1, 1. We'll continue this one on a little bit further. You get 4 gives you 7, and 5 gives you 17. So if you plot these points, we have the first thing that comes onto our screen would be 0 and 7. We have 1 and 1, 2 and negative 1, 3 and 1, 4 and 7. There's our symmetry. Now notice that our x-intercepts occur here and here, so we can say that we know that one solution is between 1 and 2, and one of the solutions is between 2 and 3. We don't know what they are exactly, and that's where the other methods give us an exact answer. So this is considered an approximation for graphing with this kind of quadratic. And this ends Section 2, Video 2.